This video is for lesson 11.4, which is correlation. So this is what we're going to be talking about. I can compute the correlation coefficient, which we refer to as R. Doesn't sound a lot like it goes with the definition, but that's what the symbol we use is R for correlation coefficient. And I can describe what the correlation coefficient, or R, measures. So I'm just going to do a quick example here. If I gave you a couple examples of scatter plots, and one of them looked like this, and one of them looked like this, and I asked you which one do you think is more strongly correlated, you would probably choose this one because the points lie closest to a straight line. So what the correlation coefficient, or R, does is it assigns a value to how strong this relationship is. So it gives it a number, so they're easy to compare. For example, this might be an R is 0.95, and this R value might be 0.57. So when you know the R value without even having a scatter plot, you know or can picture how closely related your explanatory and response variables are. So correlation is the strength of a linear relationship. A linear relationship is strong if the points lie close or in a straight line. So we'll say close to or in a straight line. The relationship is weak if the points are widely dispersed about a line. Now, the reason why the R value is important is if you take a look at these two scatter plots, and I said, which one do you think is a stronger relationship? You might say, well, this one, because the points are all closer together. But if you read down here, it says the two scatter plots above show the same data on a different scale. So this one starts at 0, and I think this one starts at, I can barely read it, 60. So what they've done is they've changed the scale to make this relationship appear better or stronger, but really it's the exact same data points. But if we had an R value on these, they would have the same R value, and then you wouldn't be confused by the picture, if you want to think about it that way. So the R value, or the correlation coefficient, is a number that indicates both the direction and strength of the relationship between the two variables. Oh, I can't remember the word that goes in there. It's in the PowerPoint, but I don't have my PowerPoint with me, or I don't have my notes with me at home. So a number that indicates both the direction and the strength of the, I think it would probably be correlation relationship between the two variables. But take a look at the PowerPoint and double check that one. Okay, so some facts and properties about correlation. Correlation requires that both variables are quantitative. Remember back in 11.1 we talked about qualitative versus quantitative, and quantitative we said could be measured with numbers. So that would be things like I can measure the height of the students, I can measure test grades, but things like eye color, that would be qualitative. So R value is always quantitative variables. The correlation coefficient is always between the numbers -1 and 1. If R is positive, then there is a positive relationship between the variables, and if R is negative, there's a negative relationship between variables. So that works out nicely. The values of R will be exactly 1 or -1 if the data points form a straight line. This is on your scatter plot. So they would look like this. Your scatter plot points would look like this. Perfect straight line in the positive direction, this would be r equals 1. Perfect straight line in the negative direction would be r equals negative 1. And then anything in the middle would always be, r is always between 1 and negative 1. So for example, you would never have an r value that was like 1.5. Or you'd never have an r value that was like negative 1.5. They're always between 1 and negative 1. So the closer r is to 1 or negative 1, the stronger the relationship between the variables is. So let's look at some scatter plots and put some r values on them. So this is a negative relationship as x increases. Here's my x1, x2. So as x increases, here's my y1, y2, y goes down. So that's a negative relationship in almost a straight line, so the r value would be negative 1. This, where you see, and so these are all negative, but they're getting a little weaker. So I'm just guessing at these r values. For r values, you'd have to have data to know for sure, and we'll put it in our calculator, find out. But this is not perfect, but it's pretty good. So I don't know, maybe that would be a negative 0.8. This is less, but you can still see the negative relationship, so maybe that would be negative 0.5-ish, we'll say. So somewhere in the 8s, somewhere in the 5s. This would be a 0, no correlation. So an example of this would be like students' hair color and how well they perform on a test. Not related at all. Perfectly positive would look like this, and the r value would be 1. And then these would be somewhere in between, but they'd be positive. So maybe this would be r equals positive 5-ish, 0.5-ish. And maybe this would be 0.9-ish. So positive, because we have a positive relationship. So here's some multiple choice. So select the most likely value of r for each scatter plot below. Well, on any multiple choice, the first thing you want to do is eliminate really bad options. Well, I already said it's between 1 and negative 1, so let's eliminate that. I'm seeing a negative relationship here. So I am seeing a relationship, so I would eliminate that. And I'm seeing a negative relationship, so it has to be this. This would be a very strong positive relationship, and I'm definitely not seeing that. This one I'm seeing a positive, and definitely a stronger positive. So it's not going to be an r equals 0. I'm not seeing a negative. So now I'm either at perfect or very strong positive. This would be strong positive. Perfect is going to look perfect. Perfect positive is going to look like this, like a straight line. So you're only going to choose those ones and negative ones when you have a straight line. So for this one, you would choose that, which would be a strong positive. Now this one, ooh, my camera is being weird. I apologize. Keeps focusing in and out. This one, definitely not a 1 or a negative 1. And this is a really strong, and this is a really strong. This looks like no relationship, and that's what it is. Okay? I apologize for the camera here. I don't know why it keeps doing that. Alright, let's go on. So now here's just some situations that we're going to pick an r value for. Without the scatter plot, and we might not need them. You do need to be able to tell for these if you have a positive or negative relationship though. So outside temperature and ice cream sales. So think Michigan. As the temperature warms up in Michigan, so if this is temperature and this is ice cream sales, as the temperature increases, right, when it's 30, not a lot of ice cream sales. When it's 80, they go up. So this is positive. So it's not going to be 0. It's not going to be perfect. It's not going to be negative. So we're going to go with positive 0.83. It's a pretty strong positive. So the number of miles a car has been driven and the price when the car is sold. So think used car. So if you have a very new used car, so we'll say, I don't know, 100 miles, very new, you're going to get a nice high price for that. But when your miles get up here to 100,000, price is going to drop significantly. So this is going to be negative, so it's not going to be R equals 0. It's not going to be perfect. This is strong positive, so it's got to be that. Kind of a medium strong negative. Height of your classmates and classmates' score on their last math test. I can tell you there is no correlation here, so this would be an R equals 0. Definitely not any of these choices because these are all very strong relationships. Okay, now we're going to find out how to calculate R values on your calculator. My notes are a little messed up here. I should have a grid here. This is the same example from 11.2 with the candy bars and the sugar and the calories. And when we talked about this in 11.2, we decided that it was a positive relationship. And we also did a scatter plot for this. So I encourage you to look back in your notes at the scatter plot for this. And you'll see the positive relationship. I'm not going to redo it in this video because we already did it. So if you look at that scatter plot back in your notes, what you're going to do here is make a prediction of what you think the R value would be. And then we're going to show you how to find the R value. So then I encourage you to put this data back in your calculator and go through these steps to see how close you were to the actual R value. For this video, I'm going to go through these calculator steps on this data. So I have already put this data from example 4 in my calculator. So what I would like you to do now is to pause the video and put this data in your calculator for example 4. And just as a reminder, you're going to start with the stats button, and then you're going to choose menu item 1. You're going to get to that screen that kind of looks like a spreadsheet, and you'll enter the data in L1 and L2. If you have old data in there, put your cursor all the way up at the top, hit clear, and then enter, and clear out your old data. Okay, so once you have that data in, let's go through these steps to find out how to find the R value. So first it says diagnostics must be turned on. So it says we want to press second 0. So let me clear out of here. So second, there's my second button, and 0. And then I'm getting a screen that looks like this, a big long list. And then it says find diagnostics on. So I want to go down, it's in alphabetical order. I want to go down to the D's. There it is. See, it says diagnostics on, diagnostics off. So I want to choose diagnostics on and press enter. And then I want to press enter again. Okay, now it says now to find R. I'm going to press the stat button again. I'll move my calculator up here, stat. And then I want to go over to calc. So use your arrow to go over to calc. And then it says what I want is menu item 4, which is that linreg ax plus b. That stands for linear regression. So we're taking the data or the scatter plot and we're trying to put a line through it. So that's what that LIN stands for linear regression. So I want to hit enter. And then do a check and make sure you have L1, L2 here listed. And remember, if you don't, these blue L1, L2, L3, that's where you would change your L1, L2s. But probably you have L1, L2 in there. So then you hit enter again a few times. Okay, so now we get, hope that didn't go out on your video, it went out on my computer screen. The R value at the bottom of the screen is the correlation coefficient. So the R value here is 0.9437, so that's like 0.944. We can keep that at 94. So for this example, calculate the value of the correlation coefficient. I'm going to say R is 0.94. So here we were looking at weight and waist size. The following table gives weight in kilograms and weight sizes for 10 students. So what does the R value tell you about the relationship between weight and weight sizes? So R equals 0.94. You could definitely describe that as a strong positive relationship. Anything in those nines is definitely a strong positive relationship. So think about weight and waist size. This is going to be a strong positive relationship. So what does it tell me? I could say that first I'm going to say that there is a strong positive relationship meaning as weight increases, waist size also increases. Okay, so I would definitely include both. I would mention that it's a strong relationship, and what it means is as waist size increases, as weight increases, weight size also increases. Or the higher a student weighs, the more likely they are to have a larger waist size. Okay, so that is it for 11.4.